Hi, I'm Tim Panson from Pipe, and I wanted to show you some stuff that we've been working on in combination with the Google Coral here, which is an AI chip on an ARM with a quad-core ARM. And what that will do is it'll run TensorFlow locally at about 20-30 frames a second on this little board that's $150 and I think probably only about 4 or 5 watts typically. I mean, the fan's not even going at the moment. And what we've got here, what you can see is this device is plugged into a USB camera. This you can barely see it, but there's a USB camera plugged in there, which is a Logitech PTZ camera. And it's now running the Pipe software here, which is connecting through WebRTC up into the browser, and then I'm doing a screen recording on top of that. Now the screen recording, I should tell you, means that the lip sync goes wrong because the recording path between the camera and the microphone is different, so you get a weird lip sync effect on here. But that's like I say, it's entirely to do with the fact that I'm doing a screen recording. You wouldn't see it in real life. So what we've got here is an AI chip and a PTZ camera, and the realization we had was that okay, it's all very well to like move the camera around. I can reach down and I can find the camera controls and I can like move it around and whatever, like this, and that's all very well, but it's actually quite awkward, and it's somewhat distracting. And so what I was thinking was it would be really interesting to see whether it's possible to get the AI chip to do that for me. And so that's what happens here. We have I have a script here running, a Python script which uses the TensorFlow APIs. We take the Pipe software, sends a copy of the video, which is currently going over WebRTC into a browser, but also sends a copy of it to a local process here, which we're starting with this script called center. And that then feeds that at some 10 or so frames a second into the AI chip, which then gives me a sense of where there is a face in there. And then I do some algorithm on it's probably not a very bright algorithm, on where that face is and then what to do based on where that face is. And so you see what happens. So we're starting the algorithm, it's found a face, it's decided to center the face, it's now doing the autofocus, and now it's zooming in to optimally place me as far as it's concerned. And there you go. So I'm now optimally placed in the view, and as you can see, you see the lip sync problem now. Right. So what's interesting about this is I can move relatively naturally, and it will follow me around the room. If I kind of shuffle in my chair or whatever, it'll correct for me being slightly off camera. If I bend down and do something over here, it'll follow me. If I get up and stand up and decide that I want to, pronounce from the heights, it'll do the right thing with that. There's a slight glitch in the overfocus there, but I mean that's entirely fixable. And so I can, I can move around relatively naturally, and this is actually really useful in a kind of COVID environment where you can't have a camera person locally doing that. So you get a lot of this kind of to camera stuff, which is very static, because you can't move around. So the idea here is that it can follow me around in a reasonably, one could make it much more subtle than this. You could make the algorithm much cleverer, but as it stands, it works, I think, pretty well. So yeah, that's what we've been doing, and this is like $150 worth of card there, and I don't know what the Logitech costs, a few $100s. So there we go. Thank you very much.